All right, now we have another function also following a quadratic model. So now we're going relative to a fixed point. It doesn't say up or down, left or right, but it's going to be one of those two things. So find the average velocity from 1 second to 4 seconds. So average velocity, in this case, I'll say v average. So that's going to be s of 4 minus s of 1 over 4 minus 1. So that's how I'm going to calculate it. The instantaneous velocity function, well, I know that v instantaneous is the derivative of the displacement function. So it's going to be negative 2t plus 6. Initial position, that's where I'm starting. So I'm starting 1 meter away, either above it or to the right of it. We don't know, we weren't told. Initial velocity, so that's going to be s prime of o. So my initial velocity is negative 2 meters per second. When is the object at rest? So that means when is it not moving? When is its velocity 0? So I want to solve v equals 0. So that's going to happen at t equals 3 seconds. What is the object's position at 6 seconds? So that's plugging into my displacement function. So I'll have negative 6 squared plus 6 squared, because I'll have 6 times 6 plus 1. So I'm back at my starting position at 1 meter away from some fixed point. Velocity at 6 seconds. So v at t equals 6. That's going to be derivative at 6. So that will be negative 12 plus 6 is negative 6 meters per second. So in this case, with my velocity being negative, it means I'm moving to the left of my fixed point. So to the left, further away. So I know that at 6 seconds I'm at my point. I'm at my starting point. So I'm moving back towards the fixed point, and then I'm going to go past it. So if we think about our fixed point being here, so we have gone away from it. So we started 1 meter away from it. So that's my starting point or my initial position. And we have gone away from it, and now we are headed back this direction, and this is at 6 seconds. So this here is at 0 seconds. So we don't know when we started coming back the other way, but at this point, we're traveling at 6 meters per second towards our fixed point, but we're very quickly going to pass it. I've made a little Desmos example for this last example we were looking at with example 4. So here was our displacement function, and I've put that into Desmos, but I've hidden it, so we know that that's a quadratic. And I've labeled our origin as our fixed point, and here's my object. So when the time is equal to 0, we know we started 1 meter away from our object to the right, and we can see as time goes on, we're getting further away from our point and then coming back past it. We can also see, so if we expand our x-axis a bit here, so we're moving to the left and right of our point, and our a values are going up by 0.2. Could have them go up by 0.1 instead. We could start at 0 again. So we can see that our object is moving faster as we're heading back towards the left. So even though our function is a quadratic, our object is really still moving away from or towards our fixed point.